Section 5.9, writing a cubic function. We're not going to do, like, even though we've looked at 5th degree and 6th degree and we've solved them, we've found the zeros, we've factored them, as far as finding an equation, we're going to just stick to cubic functions. And so let's think about how many points we need to do this. When you graph a line, how many points do you need? 2, right? What degree is a line? 1. So 1st degree line is 1, you need 2 points. What about a parabola? How many points do you need to be given? Yeah, you need to be given 3 points. And what degree for quadratic? So, quadratic equations are 2nd degree, they're parabolas, x squared. And then, so for a cubic function, how many points do you think we need? 4. So we need 1 more than the degree. So so this example, we'll do one example here together. So let's say we have to take a little time to sketch it here. So here's, just sketch with me. That's the x-axis. This is the y-axis, and we're going to give you -4, 0. It passes through -4, 0, 0, 10, 0, 10, 2, 0. Just try to put it approximately in the right place, and 5, 0. 1, 2, 3, 4, 5. Let's say that's about right here. And then, so you might be just given the points without the graph. So you should be able to do it that way, or you might find these points by looking at the graph. In this particular example, looks like the shape looks like this. So it goes up through here, and then it turns, goes down. There's your local minimum right there, and then it goes back up. I'm just reviewing as well. The end behavior, as you go to the left, the function goes up or down. In this direction, it goes down, right? And as x increases, the function goes up. That's the end behavior. That was just for review. For this particular skill that we're doing in this section, you just need this formula, which should be, you won't be given it because it's very intuitive. It goes like this: y equals. And you have some constant here that you're going to find, and you're used to that from quadratics. And then each factor, we're used to this, is, if you know the 3 zeros, p, q, and r, it's just, the factor is x minus the 0. So p, q, and r are just, you could have used any letters you want. P, q, and r are for the zeros. And what are zeros in the graph? X-intercepts. Very good. So let's do this example. In this example, we would, just by looking at it, let's start writing the equation. So you get y equals, and then a we don't know yet. We'll solve for that. And then what would the first factor be if we read the zeros from left to right? If the 0 is -4, therefore the factor is good, x plus 4. And then our other 0 is, the factor is x minus 2, good. And our other 0 is, we use x minus 5, perfect. And now, the reason, why do you think we need the 4th point to solve for? Yeah, this would be our answer, but we don't know a yet. Like this could be it. I mean, you could multiply it all out, but we need to use, so to find a, this is a typical thing that happens in other functions too. To find a, plug in the 4th point. Plug in the 4th point, which is given as 0, 10. So that's x is 0, y is 10. If we plug that in, we'll know everything except a. So once we solve for a, we're pretty much done. So I go, okay, y is 10, I replace that. A is, I don't know yet. What do I replace x with? 0. 0 plus 4. I have to put it in everywhere I see an x. 0 minus 5. So conveniently, these just become, remember PEMDAS, you do what's in parentheses first. So 0 plus 4 is 4. 0 minus 2, negative 2. 0 minus 5 is negative 5. Then we do multiplication. Any questions? Yeah. Very good. Yep. 40 times a. If you multiply these numbers together, 40a. I just changed the order. And then divide by, to solve for a. Do you divide by 10 or do you divide by 40? You want the number in front of a to go away. So you divide by 40. So it's 1/4. 10 over 40 is 1/4. So if I said, write your answer in intercept form, this would be the final answer. Y equals, you tell me, y equals 1/4 times, perfect, thank you, Hannah. That would be it. Or if you wanted to write it in standard form, which when you see the answers in the back of the book to check, you're going to see it in standard. So let's just do this for practice. Let's just multiply it out. So, bless you. Let's start with, multiplying these two binomials together for review. And this is what you had to do on your last quiz, is multiplication. And so you get x squared, and then the outer terms, when you multiply them together, you get negative 8. And the inner and the outer is 4x plus negative 2x, which is plus 2x. So do you see, if I multiply these two together, I get this, after combining like terms. And now I'm just going to distribute the x squared to both of these, the 2x to both of these, and the negative 8 to both of these. And I'll write it all in one set of parentheses. So x squared times x, tell me. X squared times negative 5. 2x times x. 2x times negative 5.
Minus 5x. Wait, oh, the minus 10.
And then negative 8. Now we'll distribute the negative 8. Negative 8 times x. And plus 40. There we go. So we're very close to being done. We just need to combine like terms. So these guys are alike, right? They're both x squareds, and these guys are alike because they're both x's. So 1/4. What do I get when I combine the x squareds? Minus 3x squared, and then minus 18x plus 40. So when you check the back of the book, there's one more step to actually get it in standard form, and that's to distribute the 1/4. Yeah, so you get 1/4 x cubed minus 3/4 x squared minus 18 over 4. Did I make a mistake anywhere? Does anyone see anything yet? It might be fine. Okay. Minus 9 halves x. And then plus 10. There might be an arithmetic mistake somewhere, but the concept is the same. The procedures are the same.